Hey everyone, today we are going to solve the Daily LeetCode challenge of 3rd April 2024 and the problem statement is word search. So let us first understand the problem statement. So according to the problem statement, we have been given a matrix of m cross n dimension. And what does this m represent? This m represents the total number of rows and this n represents the total number of columns. So here we can see that we have 3 rows and we have 4 columns, correct? So the dimension of this matrix would be 3 cross 4, okay? And we have been given a string word. And what we have to do is we have to return a true if this word exists in this matrix, and we have to return a false if it doesn't exist. Okay. Now let's understand how can this word be formed. So it has been mentioned that this word can be formed from the letters of the adjacent cells. Correct. Now what does adjacent cells means? Adjacent cells means the cell which is horizontally or vertically next to the current cell. Okay, so say for example, if this is our current cell, okay, then what does horizontal means? Horizontal means like this and this. And what does vertical means? It means like this and this. So it means that if we are in a current cell, so we can move in 4 possible directions in order to check whether this word is present in this matrix or not, correct? Because we can see that how many directions we have. We have 1, 2, 3, 4. So we can search in 4 directions, correct? And what are those 4 directions? Those 4 directions are up, down, left, and right, correct? So it means that if we are at the current cell, so let me represent the row of the current cell as R and the column of the current cell as C. Okay, what is this? This is our current cell. Then where can we move? We can move left, we can move right, we can move up, and we can move down, correct? So if this is the coordinate of our current cell, that is R comma C, then what will happen if we move left? So let's say if this is our matrix, okay, and this is the current cell and the coordinate of this cell is R comma C. Okay, now what will happen if I'll move left? If I move left, we can see that this row remains the same, whereas the column moves backward, right? That is, the column gets decremented by 1. So row will remain as it is, column will get decremented by 1, correct? Now if I move right, what will happen? So this is the current cell. If I move right, what is happening? Row is remaining the same, but the column is getting incremented by 1, correct? So it means row will remain as it is, column will get incremented by 1, correct? Now what will happen if I move up? So this is the current cell. If I move up, we can see that the column is the same, right? But what's happening? The row is getting decremented by 1, correct? So row will get decremented by 1 and column will remain as it is. Now what will happen if we'll move down? So this is the current cell. If we'll move down, we can see that the column is remaining as it is, whereas the row is getting incremented, correct? Because we can see that the row is changing, correct? So row is getting incremented and column will remain as it is. So we have found out one thing, that if this is our current cell, then at the current cell, we are having 4 possibilities, correct? That is, either we can explore the left side, right side, up or down in order to get our answer. So it means that for our current cell, we are having 4 options, correct? Now, whenever we have options, what do? Make use of recursion. Correct? Because we know that we have to do the same stuff for the left side, the same stuff for the right side, and for up and for down. So in order to do so, we'll make use of recursion. Correct? Now let's see how we can do it. So what we will do is we will start our recursion from 0, 0, 0. Now what does this first 0 represent? This first 0 represents the row of our current cell. Okay? This second 0 represents the column of our current cell. Correct? And this third 0 represents the index of this word letter. That is, we'll have a pointer over here. Let's say this is I. So this third 0 is pointing at the 0th index of this word. Correct? Now what we will do is we will firstly check that is this cell valid. Now what does it mean by checking whether a cell is valid or not? It means that we'll check that is this 0, 0 present in our matrix. So we can see that 0, 0 exists in our matrix. So it means that this is a valid cell. Okay. Now what we will do, since this is a valid cell, we will check that is the value present at 0, 0, that is at the current row or current column, equals to the value present at the ith index of what? So what is the value present at the ith index? The value present at the ith index is A, and the value present at 0, 0 is also A. So it means that these two are equal. So it means that this is a possible cell that can lead to producing this word. Correct? So what we will do is we will now explore all the 4 possibilities of this cell in order to get the next letter. Correct? So what are the possibilities? The first possibility is moving left. So what we will do from here, we will move left. Okay, I'm representing L as left. Okay. Now, if we will move left, what will happen? If we'll move left, row will remain as it is, column will get decremented by 1. So row will remain 0, column will get decremented by 1. So it means it will become -1, correct? Additionally, since the value present at 0, 0 and the 0th index of word were equal, so what we will do, we will increment this ith pointer. So this ith pointer will now point at the 1th index. So it means that now we want to check whether the value present at the current cell of the matrix equal to B or not, correct? But before that, what we'll check? So here this ith index got incremented to 1. So before that, we'll check whether this cell, that is this row comma column, is this valid or not. So we can see that as index as -1 doesn't exist, right? So it means that it is an invalid cell. So what we'll do, we'll simply return false, representing that this is an invalid cell, because since it's an invalid cell, so there is no way that we can get this word from this invalid cell, right? So we'll return a false, correct? Now what we will do, now we will explore the next possibility. And what is the next possibility? It's moving right. So if we will move right from here, so I'm representing it with R, then where will we go? So if we move right, row will remain as it is, column will get incremented by 1. So row will remain 0 and column would be 0 plus 1. That is, it would be 1. And the ith index would be pointing at the 1th index, right? That is at this B, correct? Now we will check, is this a valid cell? That is 0, 1 a valid cell? So we can see that yes, 0, 1 is a valid cell because we have 0, 1 in matrix, right? Now we will check, is the value present at 0, 1 equal to the value present at the 1th index of word? So what is the value present at the 0, 1th index? So we have 0 over here, 1 over here. So it means that the value present at the 0, 1th cell is B, correct? And what is the value present at the 1th index? The value present at 1th index is also B. So it means that these two are equal. And since these two are equal, what we will do is we will move this ith pointer forward and we will now check whether the value C is present in the adjacent cells of this B or not. And in order to do what we will do, in order to do so, we will explore all the 4 possibilities for this particular cell. That is, we will explore the adjacent cell of this 0, 1, correct? So which cell we will explore first? We will explore the left cell first. But before that, I would like to point out one more thing, okay? And that's that in this question, it has been clearly mentioned that we can't reach to the same cell again. Now, what do I mean? So say, for example, if instead of this word, if we were given a word as ABA, okay. So if we have to determine whether this ABA is present in this particular matrix or not, okay. So if you say that, okay, what we can do is we have processed this A, then we'll move to this B, we have processed this B, and then again we'll move to this A and we'll say that, yeah, ABA is present. But this would be wrong. Why? Because this A was already visited and we are visiting it again, correct? So how are we going to keep track of whether a cell has been visited or not, right? We need to keep a track of the cell that it has been visited, because if we won't keep a track whether a cell has been visited or not, then it could be a possibility that we would fall into a loop. Like if we'll have this A, B, A, so we'll say that A, then we have B, then we have A, something like that, right? So in order to not fall in that loop, what we will do is, the moment we will say that we have processed a word, what we will do is, we will change it. We will change it to a dot. So what we were earlier having A over here. So what we will do, we'll change this A to a dot. Now, why are we doing this? We are doing this in order to keep track whether this cell has been visited or not. So it means that whenever we'll encounter this dot the next time, it means that this cell has already been visited. So it means we can't visit this again, correct? So similarly, we process this B as well. So what we'll do, we will remove this B and instead of this B, we'll put a dot. Now I am putting a dot. You can put anything over here, like you can place a plus symbol, minus symbol, asterisk symbol, or anything else, okay? Now, coming back to the question again. So where we were present at the 0, 1th cell, correct? And what we found that the element present at the 0, 1th cell was B, and the element present at the 1th index was also B, and they were equal. So what we will do? Now we will explore rest of the possibilities of this 0, 1th cell in order to find this C, correct? So if we move left from this 0, 1th cell, what will happen? So we are present over here, right? 0, 1th cell, that is we are present over here. So if we move left, what does it mean? Where we will reach? We will reach to the 0, 0 cell, right? Because we can see that if we move left, what happens? Row remain as it is, column get decremented by 1. So row will remain as it is, that is 0, and column was earlier 1, so it will get decremented by 1, so it will come 0. And what about this index? This index will get incremented to 2, correct? Now what we can see that this 0, 0 cell has already been visited because we have a dot over here, correct? So since it's already visited, so it doesn't make sense to visit it again. So what we'll do, we'll simply return a false, indicating that we can't form a word using this particular cell, correct? Now we will explore the other possibility of this cell. And what is the other possibility? It's moving right, correct? So if we will move right from this cell, then where we will reach? If we are over here, if we are at 0, 1, if we move right, where we will reach? We will reach to 0, 2, correct? We'll reach to 0, 2, and this ith index will get incremented to 2, correct? Additionally, we can also see over here that row will remain as it is and column will get incremented by 1 on moving right. So row was 0, so row will remain as it is, that is 0, and column was earlier 1, so it got incremented by 1 and we got 2 over here, correct? Now we'll check, is this cell a valid cell? So we'll see that 0, 2, that is 0, 2 exists in the matrix, so it means it's a valid cell, correct? Now what we want to check, that what is the value present at 0, 2? So the value present at 0, 2 is C, correct? And what is the value present at the second index of this word? So the value present at the second index of this word is also C. So what does it mean? It means that these two are equal. So it means that this could be a possible letter that can help us to form this word, correct? So what we will do is, we will mark this C as visited. And how are we going to mark it as visited? We'll use a dot in order to mark it as visited. And what we will do, we will explore the rest of the possibilities for this particular cell, that is for 0, 2. So what is the first possibility? First possibility is moving left. So if we will move left from 0, 2, what will happen? The row will remain as it is, that is we will have 0. The column will get decremented by 1, so we'll have 1 over here. And this particular index got incremented to 3. Why? Because this C got matched. So now we want to match for this particular C, correct? So that's why this I got incremented. Now we will see that is this 0, 1 a valid cell. So we can say that no, this 0, 1 is not a valid cell. Why? Because we can see that we have a dot over here. And what does this dot represent? This dot represents that this particular cell has already been visited. So we can't visit it again. So what we will do? We will simply return a false, indicating that we can't form the word using this particular cell, that is using this 0, 1, correct? So we will explore the other possibility. Now what is the other possibility? The other possibility is moving right, correct? So if we will move right from 0, 2, what will happen? Row will remain as it is, that is we'll have 0. Column will get incremented by 1, that is we will have 2 over here, correct? And this I also got incremented by 1, so we will have 3 over here, correct? Now we'll check, is this 0, 3 a valid cell? So we can see that we have 0 over here and we have 3 over here. So yes, 0, 3 is a valid cell. Now what we want to check? We want to check that what is the value present at 0, 3. The value present at 0, 3 is E, correct? And what is the value present at the third index of word? The value present at the third index of word is C. Now are these two equal? So we can see that C and E are not equal. So what does it mean? It means that we have not found out this C, correct? And it means that if we will move in this particular direction, that is in the direction of this cell 0, 3, we won't be able to form this word, correct? Because we wanted C and we are getting a E over here. So what we will do, we'll simply return a false, indicating that we can't form this particular word if we move in this direction of this 0, 3, correct? So we explored the left possibility, we explored the right possibility for the cell 0, 2. Now we will explore the up possibility. So if we will move up from this 0, 2, what will happen? Row will get decremented by 1 and column will remain as it is. So row was earlier 0. If it gets decremented by 1, it will become -1 and column remain as it is. That is, it will be 2 only. And this I will get incremented by 1. So it would be 3 over here. Correct? Now we'll check, is this a valid cell? So we can see that -1, 2 is not a valid cell because an index as -1 never exists, correct? So what we'll do, we'll simply return a false, indicating that this is not a valid cell, correct? Now we are done with the up call as well. Now we have to explore the down possibility for the cell 0, 2. So if we will explore the down possibility for the cell 0, 2, what we'll get? On moving down, the row get incremented by 1 and column remain as it is, correct? So the row was earlier 0, it will get incremented by 1. So we will get a 1 over here and column will remain as it is, that is it will remain 2 only. And I will get incremented to 3, correct? Now we'll check, is this 1, 2 a valid cell? So we can see that 1, 2 is a valid cell, correct? Now we'll check what is the value present at 1, 2. So the value present at 1, 2 is C, correct? It's C over here. And what is the value present at the third index of word? It's C only, correct? So these two are equal. So it means that we can go in this particular cell in order to form this word, correct? So what we will do, we will mark this particular cell as visited. That is, we will change this C to a dot. And after that, what we will do, we will explore the rest of the possibilities for the cell 1, 2, correct? So if we move left from this 1, 2, what we will get? On moving left, the column get decremented by 1 and row remain as it is. So row will remain as 1, column was 2, so it will get decremented by 1. So we will have 1 over here. And this particular index I will get incremented to 4th, correct? So this I got incremented to 4th index because C got matched. So now what we want? Now we want to match this E, correct? Now we'll check, is this 1, 1 a valid cell? So we can see that 1, 1 is a valid cell, correct? So now we want to check that what is value present at 1, 1. So the value present at 1, 1 is F. And what is the value present at the 4th index? The value present at the 4th index is E. So are these two equal? These two are not equal. So what we will do? We will simply return false from here, correct? Now we will explore the right possibility for the cell 1, 2. So if we will move right, what we will have? On moving right, row remain as it is, that is it will remain 1 only, and column get incremented by 1, so it will be 3, and this ith index would be 4, correct? Now is 1, 3 a valid cell, so we can see that 1, 3 is a valid cell, correct? Now we will see that what is the value over here. So the value present at 1, 3 is S. And what is the value at the 4th index? The value at the 4th index is E. So these two are not equal. So what we'll do is simply return a false from here, correct? Now what we'll do, we are done with the left call, we are done with the right call. Now we'll explore the upper call. So we will make a call for up, correct? So if we'll move up, what will happen? Row will get decremented by 1. So row will become 0. Column will remain as it is. So column would be 2 only, and this was 4. So is this 0, 2 a valid cell? So we can see that 0, 2 is not a valid cell. Why? Because it's already visited, so we can't visit it again, right? So what we will do is we will simply return false from here, correct? Now we are done with left, right, up call. Now we'll make the down call, correct? So if we make a down call from the cell 1, 2, what will happen? Row will get incremented by 1. That is, row was earlier 1, so it will become 2. Column will remain as it is, so we will have 2 only over here. And this would be 4. Now is this 2, 2 a valid cell? So 2, 2 is a valid cell, correct? And what is the value present at 2, 2? So the value present at 2, 2 is E. And what is the value present at the 4th index of word? So the value present at the 4th index of word is E, correct? So what does it mean? It means that these two are equal. So what we will do, we will explore rest of the possibilities for the cell 2, 2. And at the same time, we will increment this index I, correct? So the I will point to the 5th index. So what we'll do, we'll first explore the left possibility. So if we will explore the left possibility, what will happen? Row will remain as it is. So we will have 2 over here. Column will get decremented by 1. So we will have 1 over here. And this ith index got incremented by 1. So we will have 5 over here. Now is this 2, 1 a valid cell? So we can see that 2, 1 is a valid cell. Now what is the value present at 2, 1? So the value present at 2, 1 is D. And what is the value present at the 5th index of word? So the value present at the 5th index of word is also D. So what does it mean? It means that these two are equal. So what we will do, we will move to explore the rest of the possibility for the cell 2, 1, correct? And at the same time, we will increment this ith index, correct? So what would be the first possibility? The first possibility would be left. So we will make a left call over here. So what will happen if we make a left call? So on making a left call, row will remain as it is. That will have 2 over here. Column will get decremented by 1. So we'll have 0 over here, and this ith index got incremented to 6. Now, what we can see over here is that we have completely processed all the elements of this word. Correct. And what does it indicate? It indicates that we have successfully found all these letters in this particular matrix, because then only we were able to move this ith pointer. Correct. Because if we won't have found out that the value present at the current index of this word and the value present at the current cell of the matrix weren't equal, then in that particular case, we won't be incrementing this I, right? So the moment this I will be equal to the length of the word, then what does it mean? It means that we have successfully found out this word in this particular matrix. What we will do, we'll simply return true from here, indicating that we have found out this word. So we'll return true over here. So we'll get a true from here. So this will return a true to this. This will return a true over here. This will return a true over here. Now you can, now since we have already got a true from here, so we don't need to explore the up and down possibility for this 0, 0 cell, because we have got that this particular word exists. So it doesn't make sense to make these two calls, right, for this 0, 0 cell. So what we will do over here, since we are getting a false from the left call of this 0, 0, and what we are getting a true from the right call of this 0, 0. So what we'll do, we'll make a OR of this false and true. And what we'll get a true, indicating that this particular word exists. One more thing that I would like to point out is I forgot to mark these as visited. So you guys don't forget to mark it as visited. Okay. So since we process these two, so we will mark these two as visited as well. Correct. Now I would like to cover one more thing. Okay. And that thing is that, do we have to make the recursive call starting from the 0, 0th cell of this particular matrix? The answer is no. We are not going to make the call always from the 0, 0 itself. Then why did we make the call from 0, 0 itself in this particular case? The answer is that in the 0, 0 itself, we had a, correct? And in the word as well, first letter was a. That's the reason why we made the recursive call starting from the 0, 0 itself, correct? Say for example, if instead of this word, we had a word as FDE, correct? So does it make any sense starting the recursive call from the 0th index? The answer is no, because we already know that the letter present at the 0, 0 of the matrix is A and the letter we want is F. So what we will do is, in that particular case, we will firstly iterate over this entire matrix, correct? That is, we are present at this particular element firstly and we'll check, is this element equal to the first letter of our word? That is this equal to F? So we'll say that no, this is not equal to F. So what we'll do, we'll move forward. We'll check, is this equal to F? This is not equal to F, we'll move forward. Is this equal to F? Not equal to F, we'll move forward. Is this equal to F? Not equal to F, we'll move forward. So we are at this element. Is this equal to F? Not equal to F, we'll move forward. Is this equal to F? So this is equal to F. So what does it mean? It means that from here, we have a possibility of getting this particular word, right? So we will start on by making the recursive call from this particular cell, that is from 1, 1 instead of 0, 0. So we'll start the recursive call starting from 1, 1. So it means that we won't start the call from 0, 0. We'll start the call from that particular cell wherever we will find out that the letter of that cell is equal to the first letter of this word, right? Because then only it makes sense to make a recursive call from there, correct? Now that we have understood this, now let us find out that what would be our base cases. So our first base case would be if our ith pointer, that is, what was our ith pointer? The ith pointer was iterating over the word which was given to us, correct? So if this ith pointer becomes equal to the size of the word, that is, it becomes equal to word dot size. In that particular case, what does it mean? It means that we were successfully able to find that particular word in the matrix. So what we'll do, we'll return a true from there, correct? Will return true. So this is our first base case. And what would be our another base case? Our another base case would be for checking whether our current cell is valid or not, correct? So what we were getting, if we will get that our column becomes less than 0, right? So if our column becomes less than 0 or if our row becomes less than 0, correct? If our row becomes less than 0, or what we can have that our column exceeds n or becomes equal to n. That is, here how many column we were having? We were having up to the third, right? So if our column value would be 4, it would be also invalid, correct? Similarly, if row becomes greater than or equal to n, correct? Or what would be the other case? The other case would be if the value present at the matrix, let us represent the matrix as board, okay? If the value present at board's current cell, correct? That is, if the value present at the current cell is not equal to the value present at the ith index of the word, correct? So in that case, what we'll do, we'll return false. Why are we returning false? Because if we'll get that a cell is not valid, what does these 4 cases mean? These 4 cases mean the cell is not valid, correct? So in that particular case, we'll return a false, because since that cell is not valid, so we can't get a word from there, right? And if the letter present at the current cell and the letter present at the current index of word are not equal, so we can't consider that particular cell, right? So these are the 2 base cases that we would have, correct? Now let's say we can have a case where our word is this, SEE, okay? And this is the matrix given to us. Okay, so what we'll do, we'll first check where we are getting this S letter. Okay, so we'll see, is this S? No. Is this S? No. Is this S? No. This S? No. Is this S? So this is yes. So this is a S and this is also S. So it means these 2 are equal. So what we will do, we will mark this as visited. Correct? We'll mark this as visited. And what we'll do, we will explore the rest of the 4 possibilities. Correct? That is left, right, up, down. So if we will move left from here, so we can see that the left cell is not valid. Correct? So what we'll do, we'll move right. So if we'll move right, we'll see that right cell is valid. Additionally, the value present at the right cell is E. And here also we have E. Correct? So what we do, we'll mark this E as visited. So we'll mark it as visited. And now what we'll do, we will explore the 4 possibility for this E in order to get this E. Correct? So what we'll do, we'll move left. So we can see left cell is already visited. So we'll return false from here. Now we'll do, we'll move right. So we can see what we have in right. In right, we have C. And here we have E. These 2 are not equal. So now what we will do, now we will move up. If we'll move up from here, we have a B, but we wanted an E. Now what we will do, now we will move down. So we have a D, but we wanted an E. So we can see that we have explored all the 4 possibilities for this E and we were not able to get this E, correct? So what does it mean? It means that from here we are not getting this particular word. So what we will do? We will backtrack. And what does backtracking means? Backtracking means we will undo the changes we made. Now what changes did we make? We marked this and this as visited. So we have to undo that change. That is, we have to mark them as unvisited. And how we will do it? We will do it by making them back to the value they were. That is, we'll change this back to S and we'll change this back to E. Correct? So it means that if we start from this S, we are not able to get this particular word C. Correct? So what we will do? Now we will again go inside that for loop in order to check that where are we getting a letter S. That is, where are we getting this first letter. Correct? So we check till here, right? So now we'll check, is this equal to S? No. Is this equal to S? No. Is this equal to S? So you can see that this is S and this is S. So it means that these two are same. So what we'll do, we'll mark this as visited. After that, what we'll do, we'll explore the four possibilities for this S. So what would be the first possibility? The first possibility would be moving left. So in left, we have a C, but we wanted an E. After that, what we'll do, we will move right. So we can see that the right cell is not valid. So what we'll do, we'll now move down. So we can see that in down, we have a E. So what we'll do, we'll mark this as visited and we'll move forward. So now what we have E. And what we'll do, we'll explore the four possibilities for this particular cell. So we'll move left. So we can see in left, we have E. Here as well, we'll have E. So we'll mark this as visited and we'll move forward. So we can see that we have completely exhausted and we'll return true, saying that we got this C and where is it? It's over here, correct? This is S-E-E. So we understood that if we find that we are not able to make this word from this, so what we have to do at that time, we have to undo the changes as well, correct? And how are we going to undo the changes? We are going to do it using backtracking. Okay. So I hope now the solution is clear. So let's quickly code this. So let us first find out the total rows. So the total rows would be board.size and total columns. So the total columns would be boards0.size. Okay. Now after that, what we discussed that first we have to loop over the entire matrix in order to find out that where are we getting the first letter of this word, right? So what we'll do, we'll say for in current row equals to 0, current row up to total rows, current row plus, and then we'll have another loop. So it would be current column equal to 0, current column less than total columns, current column plus, correct? Now what we have to check? We have to check if the letter present at the current row and current column, if it is equal to the letter present at the 0th index of the word, then what we have to do at that time, we have to make the recursive call. Okay, we have to make call to the function. Okay, so let's call the name of the function as is word present. So this is the name of the function. So what we will pass the current row, we will pass the current column, we will pass this index 0. This index 0 represents the starting index of the first letter of the word. Okay. After that, we'll pass board and we will pass word. Correct. Now, the moment we will get a true from this function call. Okay. So what does it mean? It means that this particular word is present in the matrix. So what we will do, we'll return a true from here. Correct. Otherwise, we'll return a false from here. Correct. Now let's complete this function, that is word present. So this would be a Boolean function, correct? And what are we going to pass? We are going to pass the row. We are going to pass the current column. We will pass on the current index. We are using this current index in order to iterate over this particular word, correct? And after that, what we will pass the board. So lastly, we will pass the string, but fine. Now we have to check for the base case. What was our first base case? Our first base case was that if this ith index becomes equal to the size of the word, it means that we have got the word in the matrix, so we'll return a true. So what does it mean? It means that if this current index, because we are using this current index in order to iterate over the word, right? So if this current index becomes equals to word.size, in that case, what we'll do? We'll return a true. Why? Because we have got the word, correct? So we'll return true. Now, what would be our second base case? Our second base case would be if we are present in an invalid cell. Now, what does an invalid cell mean? It means if our column is less than 0, row is less than 0, or row is greater than equal to m, column is greater than equal to m, or the value present at the current cell of the word is not equal to the value present at the current index of our word. In that case, what are we going to do? In that case, we will be returning false. So it is that invalid cell. Okay. So what would be the case? It would be if our current row becomes less than 0, or our current column becomes less than 0, or we have current row greater than equal to board dot size, or if we have current column greater than equal to board of 0 dot size, correct? Or if we have the value present at the current cell, that is at current row, current column, if this is not equal to the value present at the current index of the word, correct? Then we'll say that this is an invalid cell. So what we will do, we'll simply return false from here. Now, if it is not an invalid cell, then what does it mean? It means that the value present at the current cell is equal to the value present at the current index of word. Then what we were doing? Firstly, we were marking it as visited, right? Mark it as visited. And how we were marking it as visited? We were marking it as visited by setting board of current row, current column as a dot, correct? So what we did, we set the value present at current cell as dot in order to mark it as visited. And after marking it as visited, what we were doing? We were exploring all the possibilities, correct? And what are the possibilities that we have? We can move left, we can move right, we can move up, we can move down. So these are the 4 possibilities. So let's write the first possibility, that is moving left. So if we move left, what will happen? Current row will remain as it is, correct? Current column will get decremented by 1. Then we will pass on current index plus 1. Why are we incrementing it as 1? Because the value present at the current index was equal to the value present at the current row, current column, correct? So it means that now we have to move to the next element. So we are incrementing the index. And after that, we will pass on board and we will pass on the word, correct? So this is the left call, correct? Now after the left call, what we have to do? We have to make a OR with the right call. So what will happen in the right call? In the right call, current row will remain as it is. Current column will get incremented by 1, correct? And we will pass current index plus 1, board, and the word, correct? So now we are done with the right call. Now we have to make this up call, correct? So what will happen if we will move up? If we will move up, current row will get decremented by 1. Current column will remain as it is. After that, this will get incremented. That is, we'll have current index plus 1. Then we will pass on the board and we will pass on the word, correct? Now we are done with the up call. Now we have to make the down call. So what we will do? We write current row will get incremented by 1. Current column will remain as it is. We'll pass current index plus 1. After that, we'll have board over here. Then we'll pass word over here, correct? And what we have to do is we'll store these all in a Boolean value. Let's say it's answer, correct? So we will store it in answer. So we made the left call, we made the right call, we made the down up call and the down call, correct? Now after that, what we have to do? We discussed that if we have a case like this, like in which we have to do backtracking. So what we will do over here, we will backtrack. Now what it does, it means undo the changes. So what changes did we make? We mark the current cell as visited, right? So what we will do, we will mark it as unvisited. And how can we mark it as unvisited? We can mark it unvisited by setting its value to the value which was earlier present in it. And which value was present in it? It was word of current index, right? Because since it was equal to the value present at the current index of word, then only changed it, right? So we will set its value back to what it was, correct? And from here, we will return answer. So let's quickly run this. So it's giving us the correct answer. Let's submit it and it got accepted. Now talking about the time complexity and space complexity. So if we consider that there are m rows present in the board and there are n rows present in the matrix, then the time complexity is this. Now let me explain how. So we can see that what we are doing over here. Here we are running a for loop until we hit the total rows. It means that this is going to run for order of m time complexity because we are having a total of m rows. And this will cost us order of n time complexity because we are having a total of n columns, correct? So this would be order of m into order of n, that is we will get order of m into n, correct? Now the moment we'll find out that the value present at the current cell is equal to the first letter of the word, then what we are doing, we are making a call to this particular function. Now in this function, what we are doing? In this function, we are exploring 4 possibilities for each cell of this board, correct? So when we are exploring 4 possibilities, what does it mean? We are having 4 to the power of k. And what does this k represent? This k represents the total number of cells that we have in this board, correct? Now, if we have m number of rows and n number of columns, then what would be the value of this k? The value of this k would be nothing but m cross n, correct? So it means that this is going to cost us a time complexity of 4 to the power m cross n. Additionally, what does this k is here? So we discussed that this k would be m cross n, right? Because we will have total of m cross n cells. So we can replace this k with m cross n. Okay, so in the interview, you can explain this time complexity as this. You can also say that the time complexity is exponential. Okay, so it won't be a problem if you say like this. So you can explain that we are having order m cross n complexity over here, and since we are having 4 possibilities here, and since we have total number of cell as m cross n, so the time complexity would be 4 to the power m cross n. Now we'll say how are we getting this 4 to the power m cross n? So let's say this is 1 cell, this is 2 cell, this is 3 cell, this is 4 cell. As for now, let's consider 4 cells only, correct? So for this particular cell, how many possibilities we have? We have 4 possibilities. And for this cell, how many possibilities we have? We have 4 possibilities. Similarly, for this cell, we have 4 possibilities. And for this cell, we have 4 possibilities. That is, we can either move left, right, up or down, right? So for each of these cells, we are having 4 possibilities. So in total, it makes us 4 to the power 4 in this particular case, where this 4 represent the total number of possibilities and this 4, the second 4 represent the total number of cells. So in this particular case, how many cells we were having? We were having only 4 cells, right? So the power was 4. If we would have one more cell and that cell would have a possibility of 4, so the power would become 5, correct? So that's the reason the time complexity this function is taking is 4 to the power m cross n, and you can mention it as exponential as well. Okay. And what is the space complexity? We are not using any extra space from Rn, but since we are making use of recursion, so it would be taking a recursive stack space, correct? And what would be the recursive stack space? It would be equal to the height of the recursive tree that we were making, correct? So you can mention it like that. So that's all about today's Daily LeetCode challenge. Thank you.